Or to make it a stabilizer, I needed to add the term 0, 0, 0, 1, 1, 1, 1. Now the state I have here is stabilized by this stabilizer because it goes back and forth. Then I said to myself, okay, let's add the stabilizer IXX, IIXX. And so therefore I made each of these terms, I added 0, 1, 1, 0, 0, 1, 1, and I did the same thing to this term, so I added 0, 1, 1, 1, 1, 0, 0. Okay, so now I have 4 terms in superposition, and I've accounted for 2 x stabilizers. Then I said, okay, let's add a third independent x stabilizer. I'll add this one. So I doubled the number of terms. So I ended up with 8 terms. Now I have 3 x stabilizers. Now you can see, since there only are 8 terms, we have all the x stabilizers. There's nothing left.
So we need one more z term?
So we need 2 more z terms.
2 more.
Yeah, right? 1, 2, 3, 4, 5, 6, 7. Yeah, I'm missing 2 z's. But I guess I'm just saying this is a fairly general thing. So if somebody gives you the stabilizer group and you're trying to come up with the corresponding stabilizer state, a good thing to do is just start with the L0 string and then add in the terms that you need one at a time. And every time you add one more stabilizer, you'll double the number of terms. Or you won't change the number of terms. So for example, here I did it only for the x operators, but you can also do it for the z operators. So if I add the stabilizer z, 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 well, it doesn't change this term, it doesn't change this term, it doesn't change this term, it doesn't change this term. So it didn't double the number of terms, it just left it alone. So that can also happen. Or if for example, I guess the thing that can go wrong with this, if I added the stabilizer minus z, 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 z. Okay, so if I try that, let's do it in orange. Okay, let's do it in orange again. If you add the stabilizer minus z tensor 7, well, then 0 to the 7, when you apply this operator to it, you get minus 0 to the 7 on that, which is minus 0 to the 7. So I get minus 0 tensor 7. And this term would cancel that term out, and you just end up with the all 0. I mean, you just end up with 0 instead of a vector, instead of a length 1 vector. And so if that happens when you're trying to write down the state, what it means is that it was a mistake to start with the L0 string. You should have started with a string that has 1, 1, or an odd number of ones, and then the same procedure would have worked. Okay, so where are we? Oh, so we're missing z stabilizers. Right, so we should just look at the, here's one way of finding it. It's harder to find the z stabilizers, I think. But here we can do it. So if we look at these x stabilizers, we could write down this matrix 0, 0, 0, 1, 1, 1, 1, 0, 0, whatever. Alright, so if we call this